All right, so guys, in 6.1, the problems that we were doing, we always knew our population standard deviation. So again, just to give you a heads up, in 6.1, the problems that we were doing, the one number that we always had was we had, let me see if I can find it. Here we go. It's highlighted for you. We always had the sigma, okay? The only difference in the problems in 6.1 and 6.2, in 6.1 we had the sigma, okay? In 6.2, guys, we're not going to have the sigma. We're going to have... All right, so guys, let's go ahead and get started. The notes that I passed out to y'all are chapter 6 notes, so we're going to... finish. Okay, so in 6.2, guys, the problems we're going to have, instead of having the sigma, we're going to have the sample standard deviation, we're going to have the S, okay? So let me just do that real quick. Let me pause this, resume. Okay, so we're not going to have the sigma, that's why it says sigma is going to be unknown, right? But what we are going to have, guys, we're going to have the letter S, okay? And I'm going to kind of show you what we're going to do here. It says, if the distribution of the random variable x is approximately normal, then t, which is equal to x bar minus mu divided by s divided by the square root of n, where s represents the sample standard deviation, okay, follows with something we call a t distribution. So critical values of t are denoted by tc, where c represents the level of confidence, okay? So I want you to think about, we're doing the same thing that we did before, except instead of using the z table, guys, we're going to use something called a t table. So instead of finding a z-score, we're going to find a t-score, okay? So let's see. Properties of the t distribution. The mean, median, and mode are going to be equal to 0. The t distribution is bell-shaped and symmetric about the mean, okay? So same thing like the way the z table is, or the normal curve. The total area is still 1 or 100%, okay? Now the tails on the t distribution are thicker than those in the normal. So like here's the z table, look at the t table. It's a little bit thicker, so it's a little bit higher up here, right? And guys, there's going to be something called the degrees of freedom. So it says the t distribution is a family of curves, each determined by a parameter called degrees of freedom. The degrees of freedom are the number of free choices left after a sample statistic such as x bar is calculated. I'm going to kind of explain this to you in a minute. When you use a t distribution to estimate the population mean, the degrees of freedom is going to be one less than the sample size. So this piece right here is going to be really important for me to remember, okay? I'm going to walk you through that. It says, as the degrees of freedom increase, the t distribution approaches the normal distribution. After 30 degrees of freedom, the t distribution is very close to the normal standard distribution. Okay, so I want you to think about this sort of degrees of freedom. Okay. We have right here. Okay, so it says, suppose that there's an equal number of chairs in a classroom as there are students. So 25 chairs and 25 students. I don't know how many of us are in here right now, but I'm going to say, suppose there's 25, okay? And guys, when we're walking in, suppose I let Fred walk in first. Everybody, y'all got to wait outside. Fred's going to walk in first. Do you agree that if there were 25 seats here and there's 25 of you all, Fred would have the choice to choose to sit wherever he would want to sit, right? So he could choose all 25, any of those 25 seats, right? And then suppose Rafael came in second. Now, Rafael only has, how many seats can he choose from? 24, right? But guys, if suppose Isaac is the last person to walk in the room and there's 25 seats and there's 25 of y'all, does Isaac really get an opportunity to choose where he sits? No, because it's the only seat that's left. Isaac, I'm sorry, that's where you got to sit, right? That's sort of the idea of the degrees of freedom, okay? So I'm going to show you how to do the first couple of problems. We're going to do them a couple of ways. The first says, find the critical value, TC, for 90% confidence level when the sample size is 22. Okay, so I want to show you, in essence, what I'm doing here. I'm going to draw the same kind of picture that we had before, right? And we want a 95 or 90% confidence level, right? So guys, just like we did earlier, go like this and like this. But instead of using Z's, now I'm going to use TC. One of them is going to be negative. Let me see if I can put that over here just so that we have a lot of room and we can see it. So right here. this is going to be, the area inside there is going to be 90. This is going to be a negative TC, and this is going to be a positive TC. Okay? Now, I want you to notice it says, let's use the table, right? So there's a table right here. It says the sample size is 22. Okay? So guys, number one, if my sample size, if my number n is 22, then my degrees of freedom is going to be 22 minus 1, 21. It's always going to be one less than my sample size. Okay? What I want y'all to do for me, if you look at your packet of notes, go to the very, very, very last page. If you go to the very, very last page on your notes, is there a table on the back page there in your notes, guys? Okay, so look, what we're going to do here, we're going to go to 90% confidence level, and we're going to go to degrees of freedom being 21. So guys, I'm going to pull up the table. I have it here for us here. So look, just to kind of give you a heads up, here's my confidence level. Do you see how it says 0.90? Okay, what was our degrees of freedom? Do you remember? 21. So guys, I'm going to scroll down here, and do you see the number that I'm coming up with is 1.721? Okay. So what I'm going to do is I'm going to say, look, this, my TC is going to be 1.7, what do we say, 21? Okay. Guys, let me ask you a question. Remember when I told you that if the area inside here was 90%, right, 0.90, 0.90, the whole area is still 100%. How much would have been left here and here? 0.5 each, right? So 0.05 here, 0.05 there, right? Okay, let's do the same thing for number 2. We're going to find the critical value, TC, for a 95% confidence level when the sample size is 12. Okay, so I'm going to find my TC. I know that my N is 12, so that means that my degrees of freedom is going to be 12 minus 1, which should be 11, right? Okay. So I'm going to draw my picture. The reason I'm drawing my picture, I'm going to show you 2 ways to find your TC value, okay? So remember, one of them is going to be negative here. This one will be positive. We said that the area inside is supposed to be 0.95. So guys, if the area inside in the middle is 95%, do you all agree that that means that we have 5% left to put in those 2 pieces? So 0.025, good, thank you, Isaac. So this here, the area inside here would be 0.025, and the area inside here would be 0.025. Okay, let's do this first using the table, and then I'm going to show you how you can do the same thing using your calculator. So if I go to my table, we're going to go to 95% with a confidence or degrees of freedom of 11. Oops, sorry, wrong one. 95% right here, degrees of freedom is 11. Are y'all coming up with 2.201? Okay. So let me come back over here and write it. 2.201. Okay, so guys, I'm going to show you on your calculator how you can do this using your calculator. All right, so let me grab one of these because most of y'all have like the updated versions. And I know some of you are not going to have it, so I'm going to ask you guys, those of you who has an 83 calculator, TI-83, whether it's an 83 or 83 plus, I got 1, 2, 3. But yours is, you're good at 84. Fred, what kind is yours? 84. Okay, 83 plus. Who has 83 or 83 plus? Raise your hand. But no, you got 84. So 1, 2, 3, 4, 5. Okay, guys, I want y'all to do me a favor. You 5, come up here, guys. I'm going to ask you to do me a favor. I'm going to ask you to take one of my calculators. Guys, these are like my personal ones. Don't take these. These belong to the school.
Which ones are?
Well, I'm gonna. Yeah. Okay, so maybe this one here. And who has an 80? Who has an 84 or 83 also? Okay, come pick one of these up. Who else has an 83? What I want you to do, guys, y'all trust me, right? Okay, I'm gonna bring your. I want you to take my personal calculators. Take them with you. Bring them back Thursday. On Thursday, I'm gonna give you back yours. Yours will have a program in there so that you can do all this yourself. Yeah, I want you to bring yours too, because what I want to do. When I give you these back on Thursday, you're going to be able to do it on your own calculator, but these have it already. Okay, so guys, osmium flavor? Yes, let's see.
I think mine works
Yeah, you got it. No, you're good. Okay. You're good. Okay, so guys, if you look at your calculator here, what I want you to do I want you to hit, let me see, let me clear this out. So I want you to go second vars, okay? And guys, those of you who I just gave your calculators to, two of them were 83s. Rafael, you got an 83? And who else got the 83? Okay, but you got you two got an 83. I'm going to show you how you're going to do this right now. The rest of you guys follow along for me. Look, we're going to go to inverse t, okay? So do me a favor, hit inverse t, okay? Now look what it's asking me for. It's asking me for the area. Guys, if I switch back and I look at the first problem that we did, what was the area? Guys, this does it just like the way the other ones does. Hold on, but what's the area to the left? 0.05. Okay, so what you're gonna do right here, you're gonna type in 0.05, okay? The degrees of freedom. What was the degrees of freedom on our first problem? 21? Okay, so right here you're gonna type in 21, okay? And guys, you can just go right here, hit enter again, and let's see. Okay, do you see how this is giving me the negative one, right? So look, I'm gonna switch back over. Here we go. Because what it's really computing for me, it's computing the negative TC. So what was the answer that we came up with on our calculator? If I go to 3 decimal places, negative 1.77211, okay. When we came up with it here, wasn't it positive 1.721? So far we're good? Myra, did I lose you? Okay, so hold on. Go ahead and hit enter, right? Oh, sorry, go inverse T. Okay, does yours come up looking like you don't have inverse T? Okay, so look at the first number you're going to type in, 0.05, because that's the area to the left, right? The next number you're going to put in, you're going to type in degrees of freedom, which is 21, and then close it off. Are you coming up with a negative 1.7, so on and so forth? Okay. So Rafael and Mary, and guys, those of you who have 83s, this is how your calculators, when I get them back to you on Thursday, this is how your calculators are going to work. But definitely Rafael and Mary right now. So what I want you all to do, guys, hit the button that says program. Do you have this inverse T right here? Okay, but this is only for those of you, the 83s, okay? And guys, those of you who have 83s, those of you who turned yours in, when you get them back on Thursday, this is what they're going to have so that you can do it también. Okay? So look, I'm going to hit enter, and I'm going to hit enter one more time. What was the area to the left in our problem? What was the area to the left? Look, I got it right there. So we're going to type in 0.05. Okay? And then you're going to hit enter. It has DF. DF stands for degrees of freedom. What was our degrees of freedom? 21. So I'm going to type in 21. Okay? And I'm going to hit enter. And it's going to take me a little minute, and hopefully, maybe I didn't hit, there it is. Aren't we coming up with the same number? Okay, so guys, those of you who turned in your 83s, when you get them back on Thursday, this is how you're going to do yours when you do your degrees of freedom, okay? The 83s, it doesn't have the inverse T thing in, so I have to enter in a little program so that you can do it. But I want you all to have it so that when you're doing your homework or you're trying to keep up with stuff, you'll have those, okay? Sound good? All right. This is how y'all's is going to look. So guys, do me a favor. Look, let's check our answers. See if we're coming up with the same thing here. Okay? So again, if I show you on this calculator here, right? So look, Myra, this is how yours comes out, right? It comes out with this kind of business, with the parentheses and whatnot. Okay. So if you do me a favor, guys, on the problem that we just did, what was, on the second one that we did, what was the area to the left? Okay, so you're going to go 0.025, okay, comma. What was our degrees of freedom on that one? 11, right? And I'm going to hit enter. And guys, if we rounded it to, I want to say we were using 3 decimal places, weren't we? 2.201, is that the same thing we got here? Right? And so again, those of you guys who are going to have the 83s, if I just clear this out, and again, I go to program, hit number 1, the area to the left is 0.025, enter my, what did I do wrong? I did something wrong. That's why. So program, number one. Okay, here we go. 0.025. And my degrees of freedom was, what do we say, 11? Okay. And we should come up with the same number. It just takes a little time. There we go. Boom. That's what. It's always going to be positive. So remember when we were doing them, Joe, with the other ones, we were finding that negative ZC. What this is telling me the negative TC. Okay. So anyway, guys, you all will have your calculators like this. I'll type in those programs for y'all because it takes a little bit of time to do. All right. Now, we're going to find confidence intervals and t-distributions. Okay. So guys, this again is sort of a rehash of what we did in 6.1. We're just using a couple of things slightly different. So it says to construct a confidence interval for mu when sigma is unknown. It says the margin of error is calculated using the sample standard deviation. Guys, the sample standard deviation is that letter S, okay? So notice how we're going to do it. It says the margin of error E is computed as, and it gives me this formula right here, okay? So let's take a look at the next problem, number 3, and see if we can't figure this thing out. Okay, so it says we select 16 coffee shops and measure the temperature of the coffee sold at each of them. The sample mean of temperature is 162 degrees with a sample standard deviation of 10 degrees. Construct a 95% confidence interval for the population mean temperature of the coffee sold. Assume that the temperatures are approximated, assume that the temperatures approximated are normally distributed. Okay, so I'm going to write down a couple of pieces of information that we know. We know the mean already, right? What was the mean in this case? 162. Okay. Now, guys, we don't know sigma, but we're going to know S. S just stands for the sample standard deviation, right? That's the only thing that's different here. What is the S in this case? 10. Okay. Now, the other thing we're going to know the number N. How many coffee shops did we look at? 16. Okay. Guys, if N is 16, what would my degrees of freedom be? 15. Always going to be one less, okay? Always going to be one less. All right. And what kind of confidence interval are we looking at here? 95% confidence interval. Okay. All right. So, guys, the first thing I'm going to do, I'm going to write down my formula. So the formula says we're going to take E times TC times S divided by the square root of N. Okay. So we have a couple of options here, guys. We can either use our calculator or we can use the table to find the TC. Which one do y'all prefer? Calculator. Okay, so let's think about, we're going to use the calculator. The first thing I want to do, I'm just going to draw this basic picture like that, right? So remember what I'm going to have here? That's going to be my negative TC. That's going to be my positive TC, right? What's the area on the inside? Do we know what the area on the inside is? 95, right? So 0.95. So guys, if the area on the inside is 0.95, that tells me that I have 5% for the piece on the left and 5% for the piece on the right. But what's half of 5%? 2.5. So wouldn't that be 0.025? So the number on the inside here, guys, 0.025. Same thing for this one here. Okay. So now, remember, guys, my inverse t, or my inverse t is just like the same way that we're using the z-score. It finds the area to the left. So the area on the inside there, we said was 0.025. Again, what I'm going to do, I'm going to take my calculator. Again, guys, mine's slightly different because I have to do the little program. But I'm going to go ahead and get it set up. Okay. Now, the first number you're going to type in on yours, even if yours looks a little bit different, is the area to the left. What was the area to the left? But remember, it's not negative, right? It's just the area, because remember, area is always going to be positive, right? So 0.025, good. Okay. And then I know some of yours says degrees freedom, or yours has a comma. And the degrees of freedom, what was our degrees of freedom here? 15. Okay, guys, remember, the number that I'm going to come up with is going to be negative. All I'm going to do is make it positive, right? So let's see. Okay, so I'm coming up with 2.131. Okay, so my TC here is 2.131. Okay. Times, what is our S number in this case? 10. Divided by the square root of, what was our N number in this case? 16. Okay, so So guys, remember how you're going to do this on the calculator. The first thing I'm going to do on my calculator is clear it out, okay? So I'm going to type in 2.131, okay? And we're going to multiply that number by which one? By 10, okay, equals. Then I'm going to divide it by the square root of what number? 16. Anybody know the square root of 16, by the way? Boy, there you go, okay. And so look at the error that I'm coming up with here, guys. I'm coming up with I'm going to go 3 decimal places. 5.32, would I go 7 or 8? Okay, 5.328. So 5.328, okay? Now, let's see what that error means. Guys, notice what we're talking about. We're talking about the temperature of what? We're talking about the temperature of what, though? What are we looking at here? We're looking at the temperature of coffee. So this here would be in, oops. This would be, since we're talking about temperature, wouldn't it be in degrees? Right? Because we're talking about the temperature of coffee, right? So if the mean temperature is 162 degrees with a standard deviation of 10 degrees, the error would be 5.328 degrees también. Does that make sense so far? Okay. So guys, let me go ahead and see if we can do number 4. Okay, we'll do number 4. Let's see if we can set it up. It says you randomly select 20 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership before it was sold. The sample mean is 9.75 days. Okay, I'm going to stop right there. I want to make sure we understand what we're looking at. So we looked at 20 cars, just random, okay? But they're all the same model. So they're all Honda Accords or whatever they happen to be, okay? Or Ford F-150s, whatever you're looking at, right? And it says the number of days that each car sat on the lot before it was sold was 9.75 days. So these cars sat on there for almost 10 days before they got sold. That's what we're looking at. With a sample standard deviation of 2.39 days, construct a 90% and a 95% confidence interval. For the population mean number of days the car sits on the dealership's lot. Compare the widths of the confidence intervals. Assume the days on the lot are normally distributed. Okay, so guys, we actually kind of have 2 problems here. One of them is with what confidence interval? 90%, right? Okay, so again, guys, just to sort of think about what it is I'm doing here. Here's my picture. Negative TC, positive TC. The area on the inside is 90%. That means that we have how much percent left for each of those 2 sides? 10% each on 2 sides. Well, if it's 10% for the 2 sides, how much would one of those sides have? 0.05. So we know that the area on the inside is 0.05. Okay. So let's write down a couple of things. Number 1, let's see. How many cars are we looking at here? So my N is 20. Guys, if my N is 20, what are my degrees of freedom? 19. It's always one less, right? Okay. Now we're going to take our X bar. What was our X bar in this case? 9.75. Excellent. Okay. And what was our S number in this case? 2.39? Good. Okay. So guys, what we're going to do now, let's find our TC for the 90%. Okay. So remember, on your calculator, I'm going to get to my inverse T. So guys, remember, you're going to go second norm. You're going to go inverse T. Okay, what did we say the area to the left was? 0.05, right? So remember, that's the first number you're going to type in. And I know on some of your calculators, guys, you're going to just type in it's going to open up parentheses, 0.05, right? And then you're going to have to hit a comma. What was our degrees of freedom in this case? 19. Okay. Enter that in. And we're going to find our TC. Guys, remember, with the T values, we're going to go 3 decimal places, guys. 1.729. Okay, so my TC here is going to be 1.729. Okay. All right, guys, just to give you a heads up, if you like using the table, you can use the table. What was our confidence interval anyway? 90% with a degrees freedom of 19, right? So guys, if I go over here 90% with 19, did we come up with the same number, 1.729? Same thing, right? Okay, so it doesn't really matter which way you do it. All right, let's find our let's find our error. 90%, right? I haven't gone on to the next part yet, okay? I'm going to get there in a little bit, but I'm going to do the error first. Okay, so guys, all I'm going to do here, I'm going to copy down the formula for my error, which is this guy. Oops. Yeah, the TC times the S. So we're going to go TC times S divided by the square root of n. Okay, so let's see if we can figure this out. Let's see. We already know our TC was what? 1.729 times, what was our S in this case? Excellent, 2.39, and that's being divided by the square root of n. What was n in this case? 20. Okay, so guys, let's see if we can find the error. So let me grab my calculator, move it over here, so I got some room. Okay, so 1.729 times, what did you multiply? 2.39 equals, and then you divided it by the square root of what number? 20. Excellent. There we go. Boom. Hit enter. Are you coming up with 0.924? Good. That's what you said, right, Anna? Okay, so error is 0.924. Okay. Now, let's see. What is it asking me to do? It says, let's see. Yeah, we're going to do it. Okay, so we did construct a 90%. I want to make sure. I'll get to the 95 in a little bit. We want to find the 90% confidence interval, okay? So I got my error to be that. Now, guys, remember how we find the interval? So for the interval, we're going to do this just like we did before. We're going to go x bar minus the error, and the mu is going to be between these numbers. And I'll even write it like an interval, like, let me write it like this. So let me go this, comma, x bar plus the interval, okay? So in this case, what was our x bar? Did we already know that number? Okay, so we're going to go 9.75 minus, what did we get for our e? Our 0.924, comma, I'm going to just move this a little bit over, 9.75, would it be plus 0.924? Okay, so guys, if let's do this right here, 9.75, oops, 75 minus, what did you say, 0.924? We came up with 0.8826, is that right? Did I do something wrong? Is that right? We're good, Joe, we're good? So 8.826. Okay, and then don't I got to do the same thing, guys? But instead of minusing, I'm going to do what? Okay, Adam and Eve. So I'm going to come back over here, put a plus right there, and hit enter. 10.674. Guys, did y'all see the little second entry? And just going back and changing the minus to a plus, right? Just small things like that help you with time. 10.674, right? Okay, so look, we did this problem, didn't we? And we did it for what confidence interval? For the 90, right? Have we even touched the 95? Okay, so look, we found our confidence interval for the 90, okay? Look, let's do the same thing. I'm just going to shift this over, guys. I know, I'm sorry I didn't give you enough paper to write on there. But let's do the same thing for the 95, okay? So look, I'm just going to kind of draw a little line right here so I can do the same thing for the 95. So let me ask you a question. Do y'all agree that the n is still 20? The degrees of freedom are still 19, right? My x bar is still 9.75. My s is still 2.39. What's the only thing that's going to change here? Y'all agree that the only thing that should change is my what? My area, right? My TC is going to be the new part. So guys, think about it this way. Look, if I do this, and now we're looking at a 95% area. Negative TC here, positive TC here. If the area on the inside is 95%, that tells me that I have 5% left for the two sides, right? So guys, if I have 5% left for the two sides, how much would have been on the left side? 0.025. No, but I could have stayed home. Okay. All right. So guys, remember, you have two options. You can use the table. You can use the calculator. Whichever one you think is easier. Okay. I'm going to keep using my calculator because I spent a whole lot of time entering that program, and man, I'm going to keep using it. Right. 0.025. Okay. And our degrees freedom is still 19. Okay, but are we going to use the negative or are we going to use the positive? Positive, right? So 2.093. Okay, so the only thing I'm going to do here, guys, 2.093. Okay, so now I'm going to write down my formula for the error. Okay. Remember what the error formula is. TC times S divided by the square root of N. So let's find our error. The only thing that changed here was our TC, 2.093. What was our S in this problem? Did we already have the S? 2.39 divided by the square root of 20. Okay. So guys, let me take my calculator again right here. Clear it out. 2.093 times 2.39 equals divided by the square root of what number? 20. Okay. And I'm coming up with, how many digits did we go the first time? We went 2 digits or 3 digits? We went 3 digits. Okay, let's go 3 digits here. 1.118 or 9? Okay, so let's go like this. 1.119. Okay. All right. So guys, now remember what we're going to do. We're going to find our confidence interval. So remember, the first number is going to be x bar minus e and x bar plus e, right? So this is going to be x bar was 9.75 minus 1.119, and 9.75, isn't it plus 1.119? Okay. So guys, if I take my calculator again, 9.75 minus, you said 1.119? And did you come up with 8.631? Good. So let's see, I'm going to write 8.631 right here, 8.631. What was the other number? Yeah. Okay, 10.869. Okay, so we're almost done here, guys. We're gonna stop once we're done with this problem here. Okay, so we found the two confidence intervals. Look, one of them is 8.826, comma 10.674. The other one is 8.631, 10.869. Okay, that's a long problem because it really was asking me to do what? It was actually really asking me to do 2 problems. Okay, but look what it says. It says, compare the widths of the confidence intervals. Guys, I want you to think about the number line, okay? So look, here's my number line. Look at this number here. It's 8.8. I'm just going to I'm going to abbreviate a little bit, or I'm going to round a little bit. 8.8, and the other one is 10.6, okay? So that's this one here. Now, let me do this one. I'm going to do this one in red. My question to you, would 8.6, would that be to the right of 8.8 or to the left? To the left. So this would be 8.6. 10.8, would that be to the left or to the right of 10.6? To the right. Which one is wider? The first one or the second one? The second one. Okay, guys, remember the first one? The first one was at 90%, and the second one was at what? 95%. So the wider one was the one that had the bigger confidence interval. Does that make sense? Okay. So guys, I'm gonna stop it right here, and then we will finish up the rest of it on Thursday. Okay. So look, I'm gonna do this real quick. Un momento, por favor.